Good morning, good afternoon. This is going to be a continuation of our notes from Friday. So on Friday we started taking some notes on linear versus nonlinear functions and just showing some, not functions, but some examples of both. So that's what we're going to be continuing with today. So just to review, this is what we did on Friday. We talked about a table of values as linear if the ratio of the change in y divided by the change in x is the same between any 2 points. And we talked about how if we divided any of these 2 points, y divided by x, we got 2/3 or 4/6, which reduces to 2/3, or 8/12, which reduces to 2/3. The graphs look like a straight line. The graphs could be increasing, decreasing, horizontal, side to side, vertical, going straight up and down. The equations has a regular x in it, sometimes it's being multiplied, or in a special case, there's no x, it's just y equals a number, and that's for horizontal lines. Last, we talked about examples of nonlinear equations, and we're going to be building and adding to this. So our first example switched from decreasing to increasing. So if the pattern goes from decreasing to increasing, it's not going to be linear. In our next pattern, it's increasing, right? But our x is always going up by 1, okay? But our y, it kind of varies. It goes up 1.5, and then it might go up 3 to 6 goes up by 3, and then 6 to 12, that's an increase of 6. So if we were to compare the ratios, we'd have 1.5 over 1, okay? And then we would have 3 over 1, and then we would have 6 over 1, right? And we know that any number divided by itself is just itself, okay? Or any number divided by 1 is blank, blank, blank. Itself, okay? So that's what we talked about, right? So these are not equal, and if they're not equal, right, we use that not equal symbol. It's equals with a slash through it. Oh, we could do better. An equal sign with a slash through it, then the ratios are not the same, okay? So the ratio for y over x is not the same. Ratio for y divided by x is not the same between any two points, okay? And if you were in class, you might have heard me talk a little bit about, I remember 1.5, I told a really cute story about when I was a little girl and I used to buy this kind of popsicle. That's why it's on the screen right here. All right, we're going to look at one other type of example, all right? But I want to make sure we have enough space for it, so let's see. One other type of example, and our next example is going to be a pattern that multiplies. So our next table we write down is going to be an x, right, and then a y, and we're going to have a multiple. Okay, I was feeling a little claustrophobic in my computer screen right here, and I think that's what made me say we were doing a multiplying pattern. The next pattern actually is going to be a division type pattern. So let's just put our last table in, and we're going to use the same one, a table similar to one we did in a warm-up. So I know I said we're going to start at -1. We're actually just going to make it easy and go 1, 2, 3, 4. So if you need to adjust that in your notes, you can. Okay, and we're going to start at 10, and we're going to divide that 10 by 2 and get 5. And then let's say we divide that 10 by 3. It doesn't really matter where these numbers come from. All right, this is just an example. 2.5, okay? This is not linear, all right? For the same reason that this one isn't linear, the ratios for y over x is not going to be the same for all of them, okay? Because look at this. If you did, these are all divided by 1. Any number divided by 1 is just itself, okay? This is going down by 5, right? And this is going down by like 1.7, right? That's not the same, right? And we can say that because we're dividing by 1 here, and then this is going by 3.3 minus 2.5, so what's that, down by 80 cents? Okay, so the reasoning, the rationale for both of these is going to be the same. The ratio for y over x, it's not the same. Okay? All right, so the next thing we're going to talk about in our notes, we're going to write down just graphs of example functions that are not linear. Okay, so we're going to just keep it pretty basic. Basically anything that's not a line. Not a line. If it's not a line, not linear. Boom, that's it. So let's just do a couple little examples. There's our example 1, example 2, and example 3, right? So these are our examples. Let's make them look pretty. Let's put some X's on here, X and Y. Just to remind ourselves, our X-axis goes side to side, our Y-axis goes up and down, X and Y. Okay, let's take a look at our first one. So our first example, it might go down and then back up. So it may make like a U-type shape. See how that goes from decreasing to increasing, down and up, not linear. Okay. Our next graph, it might start out low and then grow at an increasing rate, right? So it's not linear, right? First it starts out like a slow roller coaster and then like a Speedy Gonzales one. And then our next pattern might start off the other way where it starts out like a fast roller coaster dropping down, 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 and then levels off to flat. Okay? And those are just a couple different examples of graphs that are not linear. They don't make a line. Okay? So some nonlinear examples for, let's see, the equation or the rule. Okay? Okay, so one thing is the x may have an exponent. Right? That's one thing you might have. So let's see, a rule for that might look like this. It might look like, let's do red, y equal, let's say the x has an exponent, maybe like 10x squared. That 2 up top, that little 2 up top, that's called an exponent. Y equals 10x squared, right? If you're wondering what that looks like if you were to type it, that's what it looks like, 10x squared. Okay? Our next rule that we might have, the x might have an exponent, or okay, the x is in the exponent. What does that mean? It's in the exponent. It means it's a little baby upstairs. It's a little baby up top. So how you would write that, you would say maybe y equal maybe 3 times 2 to the x, where the x is up there. See it? It's up there. Okay, and if you were going to type that out, it would look like this, y equals 3 times 2. Maybe you put the 2 in parentheses like that. Let me move this up, 2 to the x, okay? And then one other rule is that you have a regular x, okay? The x is being divided, okay? So the rule might look like this. It might be y, and it has a regular x in it, but the x is in the bottom of the division symbol, like this, 10 over x, okay? There's not really a cute way to type this in. You could say y equal, I usually do like this kind of line. We'll pretend that's a fraction line. And then at the top you have your 10. Oh, no. At the top you have your 10, and in your bottom you have your x. So maybe it looks like this. Y equals 10 up top. Division, that means division. That little fraction sign means division, 10 divided by x. Okay? So these are the notes we didn't get quite, we didn't get quite caught up on last time. How do I scroll this down? Yeah, okay. So last time when we left off with the nonlinear examples. So get these down in your notes, and this is going to help you with the next activity.